Okay, we're going to use the sine function to demonstrate a horizontal stretch. Y equals the sine of x over 2. So I'm going to start with drawing, of course, my horizontal and vertical axes. And I see that I have y equals the sine of x over 2. So y equals the sine of 1/2 x is another way to write that. That means our b value for y equals d plus a times the sine of b times x minus c. That means our b value is going to be affected. So this b value is going to be 1/2. And remember, the period is equal to 2 pi divided by 1/2. So 2 pi divided by 1/2 in this case is going to be 4 pi. Actually, 2 pi divided by 1/2 in every case is 4 pi. But in this case, the period is 4 pi. So we have 1, 2, 3, -1, -2, -3 for our y values. And then for our x values, we're going to go out to 4 pi. And the reason we're going to go out to 4 pi is because the horizontal length of our curve of our pattern is going to be 4 pi. So the period is 4 pi. So 0 to 4 pi, and then halfway is 2 pi, and then halfway is pi. Halfway between 2 pi and 4 pi is 3 pi. We'll continue the same on the left with our negatives. -4 pi, -2 pi, -3 pi, -pi. So let me just draw for you real quick in gray our parent function. Our parent function for sine starts at the midline. 2 pi later, it ends at the midline. Halfway between, it's at the midline. Halfway between the two midlines, it's at the max. Halfway between the two midlines, it's at a min. I'm just going to do a dashed line so that you can see. So you can see where we're going to end up having okay. You can see where we're going to have I don't know if you can hear that tapping. There. So that's our parent function. So that's our parent function, y equals the sine of x. Now what does this 1/2 do? It's going to take it and it's going to stretch it out even more so. So let's do this in purple. So we're going to take y equals the sine of x over 2. We're going to stretch it out even more so. So our period here is 4 pi. So sine curve starts at the midline. 4 pi later in this case, it ends at the midline. And then halfway, it's at the midline. Halfway between the midlines, it's at a max. Halfway between the midlines, it's at a min. Same thing to the left. Starts at the midline. 4 pi later ends at the midline. Halfway between at the midline. And then this time, it's going to go to a minimum when x is -pi and a maximum when x is -3 pi. And you can see, even as you draw it, you can feel the horizontal stretch. You can feel that that has just been horizontally stretched left and right, just like you've taken the ends and you've just pulled it to the left and the right, kind of like stretching, you know, stretching a band, a rubber band, left and right. And that is an example of a horizontal stretch. Now, when would you have a horizontal shrink? When do you think you might have a horizontal shrink? Well, when your b value is between, let's see, you know, I can use, this is pre-calculus, I can use the absolute value. The absolute value of b is less than 1, then it is a stretch. When the absolute value of b is greater than 1, then you have a shrink. So that means that you're going to get more cycles between 0 and 2 pi than you normally would if you have a shrink. When you're stretching, it takes you a lot longer to go through one cycle.